Thank you so much. Përshëndetje gjithë, shpresoj që jeni të kalu mirë. Thank you for sticking around to those of you that did this afternoon. My name is Egxona. I'm really excited to be here. This is my first time in kind of a security community in Kosovo. Thank you to the organizers, to all the speakers. I really enjoyed the talks throughout the day. So I will be talking about how we're using automation to scale threat detection and response. This is kind of a rough agenda. I'm going to talk a little bit about who I am and what I do. We're going to go through a review of what detection and response really is. I haven't heard so much about it today, more so on the application side or vulnerability side. So we'll go through a short overview and what that looks like. Then we're going to talk about why we even care about automation, why does it matter, and then how we might be able to apply it to different environments, what that looks like, the trade-offs around it, and then some use case examples to kind of be more of a practical guide and how you might be able to incorporate it into your environment. So as mentioned before, I'm a security engineer at Meta, or formerly known as Facebook. I've been there for about 5 years. I studied computer science at California State University, East Bay. So I've lived in the San Francisco Bay Area for a while and then moved to London more recently and been living there. I'm really passionate about diversity and specifically women representation in InfoSec. I've always been outnumbered and I'd like to change that and help as I can. I am involved in like a women in cybersecurity organization or internally at the company and initiatives to build community within that representation. If I'm not working or in front of a computer, I really enjoy being outside, traveling, spending time with my family. I'm really passionate about well-being and health and like cooking healthy meals and things like that. So now you know a little bit about me. So let's talk about detection and response. So basically what I do is I'm part of a team that responds to any malicious insider or external threats to company data infrastructure assets in general. And what that looks like in terms of what we do specifically is kind of this life cycle. So in order to find any badness in an environment, we basically have to get telemetry or we have to ingest necessary data. This might be, I don't know, network connections like DNS logs. It might be things on the host, like maybe you want to have EDR, endpoint detection system that monitors and aggregates data for you. So in order to do any kind of hunting or detecting or responding, you want to make sure you have data that's actually reliably ingested. You're not missing logs and stuff like that. The next step is hunting around that data. So basically you want to be proactive and not just wait for maybe a partner team to reach out and say, oh, there's a vulnerability and people are exploiting it, you know nothing about, and you actually have those kinds of servers and they're unpatched and blah, blah, blah. So you want to be proactive about identifying some TTPs, which stands for techniques, tactics, and procedures. So basically open source or threat intelligence in general about threat actors and or indicators of compromise that you might look for, or just in general understanding your environment. So what kind of machines you have running, what types of servers, what might anomalous look like in that environment, and that can get really detailed and in-depth, but this is just in general what we identify as hunting. Once you have actually understood what your environment looks like, what badness looks like, maybe you're feeding in threat intelligence and you're able to look against that, we go to detection, where you basically have some sort of detection engineering framework or whatever your company has to actually write a query or run some type of syntax logic to identify that event when it happens and trigger an alert for review for someone. At that stage, you would be in the response team. And so this part of the life cycle is basically where you grab that alert. Most likely someone, an investigator or analyst, is going to grab it and look at it and try to identify, is it actually badness indeed? Or maybe something happened and it's actually a false positive. So a lot of manual analysis, and investigations to try and correlate information, understand what actually happened, because the event that was flagged is quite limiting. You can't really make a lot of sense out of just maybe a single line of, a log detail, like a file event or something. So this might look different depending on the organization. Like if you're a very small company, you might outsource some of this. Like maybe you have a SOC or like you hand off actually investigating the alerts and you only get reached out to if they determine that it's something bad, or maybe, you know, you have, like, I just want to point out that this might look different. This is just what I'm used to working at a bigger company. So if we incorporate automation, this is what it might look like. And as mentioned before, it's not like conclusive. This is just my approach. So after you detect, basically, an event is flagged that something bad happened. Maybe you have a compromised host. I don't know. This is the point where ideally you should have some type of automation framework incorporated that picks up that alert and tries to do things automatically before it's even up for manual review for an investigator and engineer. So this might be data aggregation, checks against intel, or performing common steps that are manual otherwise. And those can either be generated through kind of retroactive analysis of your investigations in the past. So you can see that a lot of people are performing X activity or like action, and you're able to actually automate that. The last step here that I added, I just want to point out that ideally you have a feedback loop for all of the other components of your cycle. And the postmortem phase is kind of where you should be able to go back to your automation and say, actually, you could have done better than you did. And that's what we want. We want to be able to, once something is stood up for manual review for an investigator or engineer, they're able to then have some sort of feedback loop that either goes to detection or automation, depending on like what the limitations were. So the next step is kind of, why should I invest in automation? During my time so far in my career, I have gotten the chance to focus on different sub-areas of detection and response, and I have focused on automation a lot, and I have had the opportunity to think about trade-offs here. One of the things, sometimes my job is really exciting, other times it's a bit boring, and basically I want to be able to automate more of the boring stuff so I can do more exciting stuff. And so if I have to investigate an alert over and over again, I don't really want to do it. And so if it's a boring task and it's kind of mundane and I don't want to do it, then I'd rather have automation do it. Manual work is not really efficient. So over time, you're not going to be able to scale maybe, I don't know, hundreds of alerts per day. So having to manually go through queries, it's quite inefficient. With that comes load management. So, for example, you're going to have to hire more people to review things manually rather than investing maybe in engineers to automate some of those things away. The next step directly related is indirect false negative reduction, just because with a lot of manual review of the same things, a lot of people run into what it's called alert fatigue. And basically you're looking at things all day. And maybe you're so used to seeing this always is, this is always a false positive, and you close it out, but it was actually a true positive, and thus has led to a false negative, which means it was malicious and missed, which happens all the time and also can lead to bigger scale incidents for a company. Smaller margin of human error, basically what I mean by this is if you as a person go and run, I don't know, SQL or whatever, wherever, however you do your investigations and run analysis, you as a human are more prone to maybe missing uppercase, lowercase, or like missing, I don't know, the extension or whatever it may be. And so if you're proactive about having automatic queries run that a person can just click and it's going to run for you, you're going to reduce, the margin of error there. Over time, because you've invested proactively in automation, you're going to be able to see impact that will allow you to actually invest resources in other maybe high priority things, such as onboarding, maybe new signal into a new infrastructure of the company that you haven't really touched before. So with that, with less of the mundane and kind of boring tasks, because truthfully, there isn't always just exciting things to do. Sometimes you're going to have to deal with like low fidelity rules that are very false positive prone. And last but not least, and this is not an exhaustive list, this is just things that, I think are quite common, is detection limitations. So sometimes actually during the detection phase that I talked about in the life cycle, it's limiting. You're not able to correlate a lot of events to actually identify if something bad happened. So for example, a parent process, maybe, 3 steps down, spawned a process that's quite unusual. You're not able to upfront, maybe because limitations of most detection engineering frameworks, have kind of limitations in how dense of a logic you can run. And so you can use automation to actually, sift through things easier once an alert is escalated, from like a basic heuristic, basically. So how do I incorporate automation in my life cycle? As I mentioned, I'm used to kind of a bigger scale company where things are made, custom to the environment more often than not. So I'm not really familiar with a lot of tools out there, but I know that, for example, Jupyter notebooks are quite commonly used in the industry for this type of purpose. Commercial tooling are also available. So a lot of times if you buy EDR or you have a SIEM or something like that, they will have accompanying tooling or like things you can add on to fit your needs in terms of this concept. And then also, like, if you can influence, for example, partner teams or being able to hire maybe more of a software engineering background folks to actually build these tools on top of things, that's also possible, and that's what I'm used to most of the time. Even though I talked a lot about all the good things about automation, because I'm a fan of it, there are trade-offs to consider, and it's not always the answer. So you have to think about what works for you. So if you're kind of more on like the starting to build your program, and you don't have a lot of resources, and you likely want to invest, your costs and capacity into actually having data and aggregating logs in, maybe a formatted way and clean way, that's probably where you should invest your resources. However, I think if you are more on like balancing out how all the things work out, and you're at a place where, you have the capacity to onboard new technology, then I would vouch for it. You should think about frequency of, actions performed. Like, you don't really want to automate something that you run maybe or do once a month and it only takes 10 minutes because the reward is not that great, so the impact is not that great. So having these considerations ahead of time, there will be some maintenance overhead. The code that actually automation runs on needs to be maintained and things like that. So just wanted to call out that there is also negative things that we should consider about it. With that, we're at the use case examples. I wanted to talk about phishing because it's one of the most, talked about prevalent things that happen in the real world. And we know that it's kind of it's one of the most common initial infection vectors used, even by threat actors. But they are very false positive prone, and it's really difficult to for them to be, meaningful sometimes, and can get boring. So, in this case, what we want to do, basically think of the playbook, basically documentation you have for an engineer, or like a playbook on this is how you should investigate this. How can you write that into code? Basically, how can you script that? And think about things that you very likely will need in order to investigate this type of alert. So, for example, highly likely that you're going to need the email contents, the email headers, sender information. If it contained kind of interactive content, such as maybe URLs or attachments or other things. If it's not so much like social engineering type phishing where they want you to call them back and whatnot, but more so like a malicious email with content, you're probably likely going to want to prefetch kind of information that shows if a user interacted with it. Did they click those links? Can you see that in your network logs? Was anything downloaded? What happened? Things like that. And then probably likely, if you have an infection, is ways to remediate that inbox or the user. And so the way I have listed these things is that, for example, you can very likely automate the highly likely stuff. You can prefetch all that information for someone to review, and in case, instead of them going to run these queries manually, they will already be there and probably will take them 2 to 3 minutes to actually analyze that. If there's anything that stands out in email headers, security professional, you're probably going to see that right away instead of spending time to actually go do that. If you're unable to automate the rest of the process. So actually determining if it's bad, but basically prefetching information. So in this case, I just wanted to show a case that might be fully automated. There are other things that you might check, but this is just some of the checks you might do. So basically, you want to check if an email is indeed malicious. I don't know if I can use this. Oh. Okay. So you want to check if the email is indeed malicious. And maybe some of the checks you would do is check if the email is unexpected, the sender is uncommon, headers look off, like maybe, sender addresses don't match, SPF is off, whatever. It's trying to impersonate someone maybe that you actually communicate with, but this looks slightly different. The email has interactive content, and maybe you have kind of automated analysis in place. So oftentimes companies will have dynamic analysis available, and you can submit something for it to be run in a sandbox or something like that. And if you're able to automate that step, basically it will come back with something saying whether it was credential harvesting or not, or otherwise interesting. The other step is around if actually someone interacted with it. Because let's say we have a malicious email, but nobody did anything with it. We don't really care other than maybe adding those IOCs to some sort of tracking if you do that, or some sort of block listing, or otherwise known as blacklisting, if you do that. So in the end, if you have, for example, it looks suspicious, something is off with the email, our automated analysis shows that it's actually bad and no one interacted with it, then we can just run mediation and remediation actions, such as, for example, deleting the email, adding IOCs, so for example, domains, to block listing or tracking, or if you do threat intel tracking of some sort, and then close the case as true positive because it was indeed malicious, even though it did not lead to compromise. The other case I wanted to talk about is malware, because it's also very prevalent. Like if you work in any type of CERT team and you're responsible for a company's assets such as user laptops, you're probably going to run into a lot of commodity malware, adware, in general unwanted software like PUPs. It's going to get quite quickly, depending on the size of your company, a big volume of alerts. And basically in this case, you again want to think about how you can codify your workflow or the playbook that you work with. So being able to flag any type of event proactively before the time of alert is raised for manual review, and this might include how prevalent is this event in your environment, what does anomalous look like more on the host, then maybe the network, depending on your environment. You might want to grab suspicious events during the time that are related to downloads or network connections. Again, maybe you have dynamic analysis for binaries in place, and you can leverage that, or maybe you can vouch for that to be implemented in the future. Maybe, you're flagging against hashes matched with, things marked bad in VT, but it's actually outdated indicators, and you want to improve that, but you don't necessarily want to put it in your threat intel place where maybe you're going to get a big pile of indicators you can't really manage to update regularly. So you might be able to use automation that gets more reviewed and tested over time to allow this to some extent. So there is a lot of things you could do. This is just kind of some things to think about. And then in case of a true positive, maybe instead of, because not everything is automatable and we don't necessarily want to automate things because you need to scope an incident out. You can't just, remove that binary and close it out. Instead, maybe you can leverage automation to prefetch these informations. So point an analyst or investigator in the right way to okay, you actually need to contain this incident. What does that look like? Maybe you want to isolate the host. Maybe you want to quarantine the file only, whatever. So leveraging that in any way to save time, basically. So the recap to everything I talked about is that, in my opinion, automation is quite crucial, especially to scale an environment. At least you should try to incorporate it as you're building out your program, and however your environment looks like. There are pros and cons to consider, and not everything will be automatable, so there is still a lot of need for human expertise when doing it, especially incident response or once something is bad and figuring out to what extent and like how to remediate and contain that. And with that, thank you so much for listening. I know it's quite late.
Thank you. That was great. Thanks so much. Does anybody have any question? Rio?
I mean, first of all, thank you, Egxona. It was really interesting talk, especially seeing it from my other perspective. Basically, I just wanted to ask, because you mentioned automation a lot, is there like any cases where like automation has actually like fired back? Because, for example, like you automated something and like it happened that actually this was not a false positive, for example, or something similar.
Yes. So. Definitely. And that's why I say not everything is automatable, and it's to some extent. So I will share a case where, just going back to the phishing and like maybe the limitations with that, you could have automation check whether there was any interactive content in the email, or if it was just kind of like plain text, not really interesting. It was more of the social engineering side. And then our automation thought, okay, it's fine. The person didn't respond, so we can just close it out. And there wasn't anything flagged malicious, so we didn't delete it. But then the user saw it later and responded, and then fell for a social engineering attempt. So there is clearly limitations, but there is a lot of benefit in terms of time saved that leads to other impact. You're welcome.
I have another question.
Sure.
Is it automation done is it centralized, or you as a responders, when you see something that is occurring quite often, then you try to automate it? And the reason why I'm asking is that if you're playing this like a firefighter, if I can say, while you're responding to something, then at the same time you want to see do I want to automate this? So is it centralized, that you have a special team who looks at the data and you see, okay, I'm getting this reoccurring, so I want to automate this? Mm-hmm. Or this is mostly when you come across something that is often, then you flag it, to automate it?
I have been in both situations, and I would personally vouch more for there is a separate team, just because I think the retro-analysis aspect of it is quite valuable, trying to use metrics to actually determine the impact of an action performed, and then pushing for that project, for example, automation for a specific set of issues or specific set of threats. So let's say network-based detections, and you want to implement automation, but you want to be proactive about identifying what's actually helpful, rather than, you see an alert and you're like, I seem to be doing this every other day, I'm just going to automate it. And that's not really scalable in a good way over time, in my opinion.
It makes sense. Thanks.
Thank you so much.
I think I have another question up there, so let me just get the last question, and then we can move to our last talk, and then at 5:30 we're going to have the raffle, so stick around, please.
Thank you for your presentation. I just wanted to ask, you guys prefer to use automated tools that you guys develop, such as incorporating Yara rules with IOCs, or do you guys would rather use third-party applications such as PFSense with Elasticsearch or Kibana? So, if you could tell me more about your approach.
Yeah, it's a combination of both. We definitely have more in-house built tooling. We have had also Yara rules in the past, but it depends kind of per use case basis. For example, we do use vendor EDR in combination with in-house tooling, so it all kind of depends.
Thank you, Egxona.
Thank you so much.
Ron.